Hello, this is Mrs. Blenda here to talk with you about quotient properties. Finally, we're getting to some new content. Now, quotient properties are very similar to our product properties. We're going to see slightly inverted relationships for these. For example, our quotient properties, where I have the same base on the top and the bottom. Let's expand this out to see why our property works the way that it does. If I have 5 to the 6th power, that means that I have 5 multiplying 6 times. And if I have 5 to the 4th power, that means that I have 5 multiplying 4 times. So because everything is multiplying on the top and bottom of this fraction, anytime that I see 5 over 5, I know that I have 1. 5 over 5 is 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 1. So I have just these two 5s left over. So if I have just 5 multiplying 2 times, that means that I have 5 squared. And notice if I had looked at this 6 and this 4 from the get-go and subtracted them, I would have gotten the 2 that I ended up with in the end anyway. So that is why our quotient of powers property says that we can subtract the exponents rather than expanding it all the way out and crossing off all of our doubles, all of the instances where our same base would result in 1. I can just subtract the exponents instead. It's a little bit of a shortcut. So looking at 2 to the 7 over 2 to the 4, I know that 7 minus 4 is 3, and so that's why I end up with 2 cubed as my final answer. Okay, so we have powers above and below. We subtract the exponents to see where they go. Let's do the examples. I've got 4 to the 9 and 4 to the 7, same base, so I can go ahead and subtract those exponents. 9 minus 7 gives me 2, so I have 4 squared. That's a positive power. It stays just like it is. But if I'm looking at the second one, I have y to the 1st power. If I don't see an exponent, it's an exponent of 1. And y to the 4th power below. That means my rule tells me to subtract 1 minus 4. 1 minus 4 gives me negative 3. Because it is a negative exponent, this power is on the wrong side of the fraction line. I have to drop it below, and then we're good to go. And that's my final answer. So that's why it says subtract the exponents to see where they go. If I end up with a negative, the base, the power, ends up going on the bottom of our fraction line. All right, now this one is a bit of a combination problem. We have some rules that we've seen before, plus our new exponent rule to take, our new quotient rule to keep track of. So the first thing that I want to deal with, of course, is parentheses. I have a power on the outside of those parentheses. That means that I need to take care of that. So I'm going to go ahead and rewrite this, but I'm going to multiply those powers on the bottom, because if I have that exponent on the outside, I need to multiply. I'm not changing anything else. This is the only rule that I'm paying attention to right now. So 5 times 2 gives me 10, and then I still have that n on the outside. Now I have these same bases on the top and the bottom, so I will be using my quotient rule. Because I have 5 and 10 on those m's, 5 minus 10 will end up in having m to the negative 5 power. And then taking a look at the n's, I have n, and remember, if I don't see an exponent, it's 1. So I have, I have n to the 4 minus 1. 4 minus 1, oh, I keep trying to do that. 4 minus 1 is 3. So my bases are all in one spot now, but I do have that negative exponent, so I have one more step I need to do. I can't keep a negative exponent, my final answer. That negative means that power is on the wrong side of the fraction line, so I need to stop and make sure I drop that one below before I'm ready to be done. And there is my final answer. So let's take a look at a couple more examples where we need to combine more than one rule at a time. All right, now I like this example with the y's, and here's why. If I have the same thing on the top and the bottom of a fraction, well, that means that they're equal, and so of course it is the same thing as 1. The other thing that I can take a look at here, because I know that my quotient rule says that I subtract my exponents, well, what would my exponent be? It would be y to the 0. And this is why anything to the 0 power is 1. Because what it really means is that my exponents are balanced top and bottom, quotient style. And so they all balance out and become 1 with the universe. That's why anything to the 0 power is 1. All right, let's take a look at the next one. This one looks almost the same, but there is a slight difference. Instead of y squared and y squared, I have y to the negative 2. So they are, in fact, not the same. That negative makes a significant difference because that means that power is on the wrong side of the fraction line. So that y squared doesn't belong on the bottom. It belongs on the top. So instead of subtracting those, although you could subtract them, I'm actually going to end up adding them. So that means I've got 2 plus 2 gives me y to the 4th power, and I've got a 4 on the bottom. Now, one more thing. Because I have 2 over 4, this is where I was talking about last time, where if I have a number top and bottom, they need to be simplified. 2 over 4 is the same as 1/2. So I will write that as 1 over 2. And now I have a simplified answer. And that would be my final answer. There is another way that we can do this. Let's take a look at it. If I was using my quotient rules instead, let's say I want to use my quotient rules because we just learned them. These do have the same base. They both have a base of y. So if I use my quotient rule instead, what I'm really looking at there is that y squared minus, and that one on the bottom, that exponent on the bottom is negative 2 over 4. So if I take 2 minus a negative 2, I'm still going to end with y to the 4th power, right? So even if I use my rules in a slightly different way, I still end up with exactly the same simplified answer. So if you see one rule that you want to use before another, go for it, okay? It doesn't really matter. They're still going to combine to get you the same simplified answer in the end. All right, let's look at this last example. There's kind of a lot going on here. First thing that I want to take a look at is the parentheses, right? They sort of stand out, so it makes it easy to take care of that first. Because I have an exponent on the outside and more than one base, I need to remember that I'm going to bring this to each base on the inside. And if I don't see an exponent, that really means it has an exponent of 1. So I'm going to rewrite that top, having multiplied that outside exponent in. So I now have 4 times 2 is 8, and 1 times 2 is 2. So there's the top. And let's take a look at the bottom. What can I do with the bottom? On the bottom, I see that I do have the same base of x, so that means I can add those exponents. So 3 plus negative 1 gives me 2, and then the y cubed is still there. There are no other same bases with the y's on the bottom. At this point, I see that I have the same base top and bottom. This is where I need to use my quotient rule. So I'm thinking I have x to the 8 minus 2, and I have y to the 2 minus 3. That will end up being x to the 6th power and y to the negative 1 power. Because it's a negative 1, that actually means it's on the wrong side of the fraction line and needs to end up on the bottom. Okay. So we may have more than one rule to use at a time, but we just need to pay attention to them one at a time and get down to our simplified answer where we don't have any negative exponents, no bases appearing more than one time, no parentheses, and simplified fractions as much as possible. Okay, so there is our first quotient rule.